Consider the following problems. Create a class that contains two variables of type int. Make get and set methods for each variable. So then I can just make a class that contains two variables of type int. But then the second problem. Create a class that contains two variables of type string. Make get and set methods for each variable. So then I have to create another class even though it's very similar to the previous class. And now the third problem, create a class that contains two variables of type scanner and make get and set methods. So I'm going to have to do that again for the third problem. And then the fourth problem, create a class that contains one variable of type int and one variable of type string. Make get and set methods for each variable, and I'm going to have to create another class for that. So this is pretty inefficient because I have to create 4 classes for these 4 problems. And why create 4 classes when I can just create one class for all 4 of those problems? So in order to do that, we create something called a generic class. Let's name it pair, and let's make it have 2 type parameters, a and b. So that when I create variables of type pair, I can create one of them where a is integer, b is integer, another one where a is string and b is string, and so on. Now let's create our instance variables. So public a first, public b second, then a constructor. And the constructor doesn't need these angle brackets, which are really less than or greater than signs. Now let's make our get and set methods. So first, public void set first equals a, public a get first, return first, then public void set second equals b, then public b get second, return second, and then we're done. Basically, now for the 2 variables of type int, we just need to use pair of integer and integer. So a is replaced with integer here, and b is replaced with integer. And then for the string problem, we just have to use pair of string comma string. For the third problem, we would just need pair of scanner comma scanner. And for the fourth problem, we would just need pair of integer and string. Our ability to accept type parameters, which are not fixed during the compilation and can be replaced with anything during the runtime when we create objects of these, allow us to combine these 4 problems into one and only need one class to do all 4 of them. And in fact, much more than 4. Like we can make pair of double comma scanner, and so on. The reason we're using integer and capital double instead of int and lowercase double is because primitive data types are not generic types. They cannot be put inside angle brackets. So for example, pair of int comma int p6, that's not allowed because this thing needs to be a reference type. It needs to have properties of an object. However, you are allowed to put arrays inside these brackets. So like this is allowed. Like that, for example. And in the extreme case, you're also allowed to put pairs or other generic classes inside here. It's like pair of integer comma integer and string p8, for example. Another example of a generic class that we've been working with is ArrayList. Note that it shares basically the same properties. For example, you can't make array lists of primitive data types. You could with arrays and array lists or other generic classes though. Now, here's an example of when you shouldn't use generic classes. So let's just say we have a rectangle. And then let's just say we have something like this. Now, there's multiple problems with this. So basically, if we try to create an area method, first of all, what would the type even be? There would be no way to do so because I can't just do return length times width. That would be pretty bad because length is of type A, width is of type B, and A doesn't have to be like, A can be scanner or string or something. You can't just casually multiply that. And so this is an example of why you shouldn't use generic classes like every single time, because even though A can be like int or double, we can't do anything with this because A can be scanner, it can be string, it can be array list, or it can even be rectangle. So you don't want that. Let's do this example. So create a generic class named myArray. So class myArray that accepts one type parameter, E, and has an instance variable of type array of E. So private E array. Create a constructor that sets the array to an array of length 0. So for this one, ARR equals new E0. So this would actually not work. This would be called a generic array creation, which is not allowed. In fact, even if I wanted to set it to like a positive number, like 5, I can't do that. In general, I can't do new and then an array of a generic type. That's not allowed in Java. Instead, what I need to do is cast an array of object I create to an array of E, like that. And it may cause a warning, but the thing still compiles. So then, like this, or in the problem, array of like 0, like that. So then next, create a method named add that takes a value of type E. So public void add value of type E, and adds it to the array. So for this one, again, since array has a fixed length, I'm gonna need to make a new array. So say temp equals, again, I need to do the casting, new object arr.length plus 1. Then afterward, for int I equals, basically for every element of the array, I add it to temp. Then I add the final element to temp. Then afterward, I set ARR to temp. And again, you can ignore all compiler warnings. And create get and set methods for the array. So for this one, public void set int index and e value. And for this one, I just do arr of index equals value. And then lastly, public e get int index return arr of index. And then it works. So now when I create a my array of say integer and name that m equals new my array of integer, and then let's just say m.add 5, m.add 7, m.set 0, 3, print m.get 0, and it should output 3 as shown below. And notice that my array acts just like ArrayList, except it's just much simpler.